Module 4, Different User Needs. This session will focus on the different end users of road safety data and how they analyze, interpret, and use information. Examples will be provided on how policymakers, police, road safety engineers, health sectors, and vehicle manufacturers all use crash and non-crash data to help develop strategies, identify risk locations, and provide appropriate solutions. Dr. Turner will start Module 4.
This morning is talking about the different user needs. And this links very closely to the discussion yesterday that we had, that we need to undertake a stakeholder analysis to understand the needs of different road users. I'm going to talk about this now in a lot more detail about some of the key users of our road safety information, because it's very important for you to understand how different people use information so that you can plan and understand what information needs to be collected, but also how best to give this information to your key stakeholders. So we'll be looking at different users of data and what they need. And the examples I'll give in terms of detail, we'll talk firstly about policymakers, people in senior positions in government, politicians. What can we give these people? What information do they need to help make decisions? We have to make life easy for these people. They're busy people. They're reading lots of different material. Sometimes they have no interest in road safety. So we need to have a special way to present information to this group. Road safety engineers. What does a road safety engineer need information for? How do they go about the process of improving safety? And I'll give you a little introduction to this black spot study process that Greg mentioned earlier. We'll talk about the steps that are taken for traffic engineers to help improve road safety. And again, this is a very basic introduction, but it's important for you to understand how information is used. The police, and some examples of how police can use this information. And again, this important link with the police, because they collect information, but they also use information. And then very briefly, we'll return to some other users of road safety data. And then lastly, we'll talk about how best to present this information, how best to report our data, different styles of presenting information. Okay, so firstly, policymakers. How is information used at that policy level? So it's things like inform the development of a strategy. We're interested in these things like long-term trends. What are the main crash problem types? Motorcycles. We need the information to understand what our key problems are and the change over time. Is this problem getting worse, or is this problem getting better? So we need this safety data to analyze, to understand at the national level, or maybe at a region level, provincial level, what are the key road safety problems? Is it bicycles? Is it pedestrians? Motorcycles? Is it younger people, older people? So it's very basic information, but it is all based on evidence. It's based on the data that has been collected. This information is also used to help track our performance. We talked yesterday about this pyramid, the triangle. We need information to set targets, but then we need to understand, are our interventions working? Our intervention might be speed reduction. We've increased our enforcement for speed reduction. What is changing with these road users? Are speeds becoming lower? And what is happening in terms of the crash outcomes? Are crashes decreasing? So we can use this information to track our performance to see if we're being successful. And if we're not being successful, we can try something different. That's very important. If we are doing something that's not successful, then we are wasting money, maybe. It helps us plan these campaigns, so we maybe know that speed is a problem. We can do more enforcement, we can do more education, we can do training. It helps us plan these types of programs. It tells us where these problems are worse. It might be that in your country it is worse in one place and not so bad in another place. It's also very important for resource allocation. At a whole country level, there may be certain parts of the country that have a worse problem. And it may be more money needs to be spent in that location. Maybe not equal every place. maybe it's the worst place that gets more resources. If we don't have this information, we're not able to plan this resource allocation, the money, and how we spend it. Examples of the types of information that is of interest. Again, is it children who are having a bad problem? Is it young males? We have problems with our young men when they first start to drive. They want to drive very fast and aggressive. This is a problem area, so we can analyse our data to understand these problems. Things like time of day of week. Is there a problem at the weekend or a Friday? Is there a problem during a holiday period? This is often a very big problem for our countries. A lot of people move big distances during these holiday periods. Sometimes there's a lot of alcohol involved. It's very important for us to understand this sort of information and report back this information to policymakers to help plan campaigns, to help plan enforcement and other things. Weather conditions, road-related factors. We saw IRAP before, and some of the types of information that is interesting for us to help plan improvements in the roads. Objects struck. Are there objects on the road? Are there objects on the side of the road? It helps us plan a big campaign or program for infrastructure improvement, changes to the road. Vehicle types. Motorcycles, are they the big problem? Is it motorcycles on our high-speed roads, or is it motorcycles in our cities? All of this information is useful to help us identify the problem, identify some solutions, and then monitor what is happening. We can look at trends over time. This is a very simple analysis. This is per year. 1951, 1952, 1953. Population, number of vehicles, number of injuries, and then things like fatalities per population. And we can see the change over time. This is simple information, but it shows, is the problem getting worse or is the problem getting better? This information, though, is too complex for a policymaker, for a senior manager. They won't want to see numbers like this. They want to see this information. Simple. It's easy to see that over time, 1950, increase. 1970, it's been decreasing. Simple information that they can understand and look at quickly. You only have a short time with politicians. You need to give them simple information. There's different ways to compare crash numbers. This is deaths per vehicle, deaths per population, per capita. And again, this is different ways to present the same information. This is another way to compare information. On this side here is the percent of all of our fatal crashes. On this side here, percent of all of our injury crashes. Where is our biggest problem? Very easy to see for fatals, this one. Lost control while cornering. Driving on the road, come to a corner on the road, lose control. It's very easy to see quickly what our major problem is here. What's our number 2 problem? Easy, this one. Head-on crashes. So different ways to display information in a simple way for people to see quickly the problems. I'll just give you some more examples now, just to make you think about some ways you can present information. I'm not saying you should do all of these things, but it's just for examples. So in this case, this is the number of crashes, or percent of injuries during different days of the week, but also during different times of the day. And in this case, it's interesting to see, Monday through Friday, there is a peak, 2 peaks each day. This is because people drive to work in the morning and drive home from work in the afternoon. But at the weekend, people aren't working the same. This is another example of how to show that same information. But this one here is for alcohol offenders, drink driving. In this location, no problems. Little problems maybe here at night time. So this is for one day, this is middle day, this is end of the day. Some problems, big problems. Thursday night, time. Friday night, biggest problem. Saturday night. So we can straight away tell the police, this is the problem times. And you probably know this already. You probably understand this already. But this is an easy way to display information to help plan strategies and campaigns. Maps, I mentioned maps yesterday. This is a very powerful tool to help us understand the problems, but but also to put in front of our policymakers, our politicians, our mayors and other important people. They can look at a map. This is a map of a part of a country. All these dots are crashes. They can look at the map and see where the problems are. And they can see so many dots, so many problems. So a very powerful way to display information. This one here is for a whole country, for the country of New Zealand. Different colours show where the worst problems are. And again, you can quickly see we really need to do something in here and here. These are our worst places. So again, it helps plan strategies. We won't spend so much here and here. We'll spend not so much here. So we can allocate resources. Our politicians can understand the importance to allocate resources in the places that are worst. This one here is a little bit old now. So this is a powerful tool to compare and to have competition. Sometimes people are scared of competition. It shows that their neighbours are doing better. But for me, this is a very important thing for road safety. We can say, we need to get better. We need to be like our neighbour. They are doing better than us. We can use this as a way to increase interest in road safety. In this case, there's a way to compare the average for a country in different types of crash types. This top one here, percent of crashes exceeding the speed limit. The range in this country is between 9% and 33% is the sort of range where different areas, that's the percent they have where speed is a problem. For this one location, their speed problem is 13% of all their crashes is from speed. So they are in the lower end. They're not so bad on this measure. But other things, intersection crashes. 33% of their crashes happen at intersections. This is near the top of the range for this location. Similarly, cyclists. The range for all the country is between 0 and 15%. For this location, 12%. It means they're near the top. They're performing not so well as many other places in this country. So again, this comparison is a very, very powerful way to say we need to do more about cyclists in our location. We need to do more at our intersections. Maybe not so much, we'll do some things about speeding, but maybe not so much about speeding. So comparison with your neighbours, but also comparisons inside your own countries. This city, this is this city, this town and this town. How do they compare? Can they start to compete and try to win and get the best results? I'm now going to move on to a little bit of detail about how road safety engineers use safety data. So road safety engineers, they use crash data to target the high risk locations, the worst places first. We can't do everything in 1 year. We can't do everything in 10 years. It'll take us 50 years. But we start with the worst places, the places we can make the biggest change first. I'll just point out this document here. This is by our national organisation called Austroads. This is the Guide to Treatment of Crash Locations. This guide is now available for free to you in your country. If you send me an email, I will be able to arrange for you to get free this document to use in your country. So all of the information I will present comes from this document. If you have engineers, road safety engineers in your country who need to learn more, this is a good starting document. Now this presentation is based on one that is given in Australia and in other countries around the world. It is produced by Mr. Robert Morgan and my boss in my office, Mr. Michael Ziotis. And I'd like to say thank you to them for letting me use this material today. Step by step, the process involves identifying high crash locations, either an intersection or a place on the road where there are high numbers of crashes happening, all from crash data. You can identify crash types that are similar. What are the main or the predominant crash types? We saw earlier head-on crashes and run-off road crashes, often at these locations. Become a detective and understand the cause of these crashes. Why are they happening? And that will then help us understand what can change, what can we do to improve. And that's called the treatment, or sometimes called the countermeasure. This is the name we give to things we do to change and improve road safety on the roads. Treatments must be effective because of this budget constraint. We all have small budgets, so therefore we must use this information to help us prioritise, to be effective in how we use this information. And lastly, the last session that we'll talk about today is monitoring and evaluation. Very important. Did this work? Will we do this again? How can we do this better in the future? This diagram is in your notes. Very complicated looking diagram, but it's really quite simple. I'll take a step through all of these processes now, so do not read this now, but it's for your reference for later. I will tell you the process and the steps we take when we do treatment of crash locations. First of all, we decide on what locations are we after. We need to start to narrow down. Are we talking about a small area? How do we define a black spot? And for many of your countries, that could be one spot on the road. It could be an intersection, or it could be a bend in the road that is a very bad one. Or it may be that we look at a route, maybe 1 kilometre long, and we can understand in these locations where are the worst lengths of road. Which road on your network has got the highest number of fatal and serious crashes? So this requires crash data, and it requires analysis for us to count the crashes at these locations. So like we said yesterday, a very important tool for your data systems is to be able to analyse the data and to produce this information for engineers. Secondly, we define the time period. Are we interested in crashes over the last 1 year or 2 years or 5 years? We tend to use 5 years in our country because we have now less crashes. But in your countries, maybe 2 or 3 years, all of the crash data combined is enough to tell you where your worst locations are. A very, very powerful tool is just to map crash locations. In this case, as I said yesterday, you can see a group here, including a fatal crash, a group here, a group here, a group on the edge of the page there. These are all places that may be of higher risk. And so this gives us information about where we for an area. Each row here is one location. So an analysis has happened, the count has happened in the data system. And they're able to say, at this location, at the Boulder Road is the name of the road, at Great Eastern Highway. So we know where this location is. At this location there have been, over this period of time, 26 rear-end crashes, cars bumping the back of another car. There have been 7 side swipes, cars bumping the side of the cars. All of these other crash types. Also information about many of these happening at night. This is a very large number at night. Why at night time? What is the problem? And straight away, as a detective, we can say nighttime crashes, maybe lighting is needed here. Okay, so this information already starts to tell us what could be going wrong. This is another listing from another location. This one here I showed yesterday, the worst location isn't the highest crash number. There's one down here, 18 crashes. The top one is less, 11. Why is that a worse location? It is because there were more serious crashes involved. Our main objective in road safety is to reduce and eventually eliminate, get rid of fatal and serious injuries. So therefore, it is more important for us to look at the high serious ones. If we do this analysis using our crash data, we may have hundreds of locations where there are crashes occurring, too many crashes. We cannot go and look at all of these crashes in 1 year. It is impossible. There's too many. We don't have enough money. We don't have enough people. So what we will do is we'll say this year we will look at the top 20 locations or the top 10, however many resources we have. We'll do as many as we can this year and as many the next year. We'll go and assess our worst locations first. This is showing different crash types. This is from New Zealand. This is their vehicle movement coding sheet. Most countries have a similar sheet. It may look different, but the process will be similar. This in rows are different types of overtaking and lane change crashes. So when the police fill in their form, they will say it is this crash type or this crash type. This is a diagram to show what has happened. Or if it's not the police, it is the people that enter information into the database. They will be a detective and they will say, this is the crash type. In this case, it is a head-on crash. Or, in this case, it is a pedestrian-type crash down the bottom. So these rows are different crash types. But in this country, they have more detail. They have different types of crashes. They have head-on of different types to give even more detail to help you be a better detective. So this is information that is useful for engineers to understand more about the crashes very quickly by looking at these pictures. A single crash is not an indication of a problem that can be easily addressed. In this case, there are 1, 2, 3, 4 crashes, but they're all different crashes. There's a problem here, but it is very hard to solve a problem when it has got different causes. In this case, one car coming up here, another car coming through here hitting. This one here, cars coming this way, one coming this way, hitting. This car here trying to turn right, hitting a car coming straight through. This one here driving, losing control, running off the road. All different crash types. For us to understand this problem is quite difficult, and it's quite hard to actually solve this problem when all crash types are different. I'll compare that to a situation where there are only 3 crashes, but they're all the same. It's a lot easier for us to identify the cause, but also solutions when crash problems are the same. And that's where those diagrams come in easy. For us to put this on a map or a diagram helps us draw the crash types and easily see these patterns. In this case, car driving through, been hit. Car driving through, hit. Car driving through, hit. What is happening here? We can become a detective and we can say there might be some issues here with, is there a stop sign here? Who is supposed to stop? Who is supposed to let the other car go first? Is it easy for these people to see this is an intersection? Maybe they can't see. It's hard to know this is an intersection. So we can start to be a detective even before we see photos of the site or visit the site. This is more complex. This is a lot more crashes, but the same issue. In this case here, you've got different crash types. Vehicle driving through, hit. Vehicle driving through, hit. Many of the same crash type. And then other crash types as well. In this case here, we know that there is a give way sign. Cars driving this way must stop and let these cars go first. So there's a problem, I think. Cars are not stopping here. What is happening so that cars are not stopping? Again, become a detective. We can analyse in more detail the causation of these crashes. We can look at the time of day, the day of week. Are they all happening on the same day? Are they all happening at night time? Are they all happening to pedestrians? What are the common causes of crashes? And again, this helps us become a detective to find solutions. So some systems can create these automatically, these charts that summarize information. Other times we need to do ourselves our own tables to collect the information, to use our engineers to draw pictures. This is okay as well. I showed yesterday already the slide about a site summary. This summarizes all of the problems at this location. Again, more information to help us be a detective. But again, all information from our crash database. Back to our example. You remember, give way here, cars driving through, being hit. Car driving through, it should stop, it must stop. This photo shows this intersection. Here is the sign saying, give way, you must stop. But for some reason, cars are driving through and not stopping. Can you see some reasons why this might happen? For me, it is very hard to understand that this is an intersection. This sign is very small. So many people probably are not seeing the sign and they're not knowing they need to stop. They're driving straight through. Usually we would go out and visit the location, inspect the site, take our experts to these locations, our engineers, but also our local police as well sometimes, or other experts. And we will discuss these locations and we will become detectives and we will say, in this location there is a problem. This sign we cannot see. So we need to do something to make that easier to understand for our drivers. And so we have some solutions already. We know that in this location there's no line markings to say or to show easily they should stop. there is no sign that is clear, maybe a bigger sign. Another solution is we can make a little island here and put another sign to make it more obvious this is a place people should stop. So these are cheap solutions. These will cost only $100 or $200, but it will save all of these problems, just like that. Easy, cheap. That is what we're looking for, easy and cheap solutions that will give us big benefits. While we are here, we will also look at these other crash problems. There may be some solutions for these as well. Long term, if there is still a problem, we can do more expensive things. Maybe we can put in a roundabout here. Maybe we can do other things as well. But for now, let's try the cheap things because we have so many places to try and improve. So we will try easy options first. Some of the solutions. That's all in your notes. I won't show any slides on this, but they will then go back to their office and they will create a design. They will say, a bigger sign here, paint line marking on the road to make this a more obvious location. They'll then do a benefit analysis and cost analysis. How many of these crashes will be saved if we do this? We could probably say that most of these crashes will now stop. Not all, probably, but most of them will probably stop now. So these numbers we can turn into crash cost savings. For every crash, there is a cost. We can say maybe there are 8 crashes that have been saved. Each crash might be $50,000, and so you can do the sums on that to know how much saving there will be in the costs. We can also calculate how much it will cost us. What will it cost us to draw some paint on the road? What will it cost us to put in a bigger sign? This might only be several $100s. And then we can say, these are our costs, these are our benefits, and we can say, for every dollar we spend, we will get a very big benefit here. Okay? So we do this for all of our sites that we're investigating in 1 year, all 20 sites or whatever number. And we say, out of all of these, our benefit will be best at this location here because it is cheap for us to treat this location and we'll have big savings in our fatal and serious crashes. And this is how we prioritize. This year, out of those 20 sites, maybe we can only pay to treat 5 of those sites, but we need to choose the worst ones first. Okay? Following that, you have your 5 locations you want to make changes to. You'll go out and build or change, put the sign in, do the painting on the road. So you implement the treatment. And then the last step, you'll keep a watch. You'll come back in 1 year's time and look at the information. Has there been an improvement? Do we need to do more? Did something go wrong? Did crashes increase more? This can sometimes happen as well. We need to monitor and also to evaluate. And this tells us, yes, better signs did work. In future, we can be sure that this will have benefits for other locations as well. Or if we did something that didn't work, we can say, in this location, it wasn't so good. So in future, similar locations, we need to do something different. There are other types of information that are of interest to road safety engineers. We can also, though, bring in other information that we spoke about, traffic volumes, the number of cars or motorcycles. And this allows us to do some comparisons in terms of safety performance. I won't go into detail on this because it gets a little bit complicated, but I can tell from my data in Australia how safe are roads that are going 2 ways, but no separation, no barriers. How safe are they compared to roads that do have separation or barriers? And I know the crash rates. This tells me here that the fatal crash rate is more than double. I have very high crash numbers on roads that have no protection. This helps me to design projects across all of my roads, and it helps set policy across all of the roads. In future, we will put more of these barriers in the middle of the roads. So this is very useful analysis that engineers can use and help inform policy. Again, a little bit complicated, you don't need to understand this, but the key point here is we can combine crash data with other data to do more powerful analysis. Some of your countries probably are already at the stage where you can start to do this analysis yourself now. Police. The crash data and how this can be used by police to inform enforcement programs, but also inform resource allocations as well. So what are the factors that are of interest to the police? Were crashes happening at intersections? Which ones were the fatal and serious ones? Also issues relating to vehicle defects. Was it to do with a truck having a problem that caused the crash? We can do analyses on all of these factors across our whole country, and we can say in this area speed is a problem, or for our whole country there is problems with vehicle defects for trucks. And we can start to plan policies and enforcement programs to address this problem. A regional level, provincial level, or at a location. We can even go down to an intersection and say, this intersection here, there's been a lot of problems with seatbelts. All the crashes that have happened, no one's wearing seatbelts. Maybe we can do some enforcement. Or in this area over here, there's a lot of crashes, but they all wear helmets. In this location here, the crash problem is worse, more serious crashes, but no one seems to be wearing a helmet. So this helps us understand where we should plan our campaigns and our enforcement. So this linkage between this crash data and our enforcement campaigns, but also our education programs, our training programs, our publicity as well. We can also combine the crash data with other sources of information collected by the police. The number of penalties or notices issued can be useful information to put into a database. I think some tables spoke about this yesterday as one of the issues for data. So the types of information that the police want to analyse, would like us to analyse for them. What are our biggest problems? Is it things like speed? Is it drink driving? Is it helmets? Again, we need the data to analyse. We need to use evidence. We can't guess. Otherwise we'll waste resources. We need to have evidence to know this is where we need to spend our money.